our diagram and look for a pattern. So sometimes it's easier to figure out a problem by either drawing it out or by looking for a pattern. And sometimes you can combine the two by looking for simpler versions. So it's usually easiest to see how this works by looking at a couple of problems. So here's one. This here is Spam. I used to love Spam when I was a kid. At least the Spam meatballs my mom used to make. But now I don't eat it anymore since I'm a vegetarian. But I never knew there were so many types of Spam. But back on this topic here. Now, if we were to make a pyramid of Spam cans, then we would go ahead and see, well, there's 1, 2, 3, 4, 5 rows there. How many are needed for 9? And we start looking and say, okay, for one row, it's just going to be 1 for one row. For 2 rows, it's going to be a total of 3 because it's 1 plus 2. For 3 rows, it's going to be 1 plus 2 plus 3. And that's going to be equal to a total of 6. And you can get the idea. 1, 3, 6. The 4 is going to be 1 plus 2 plus 3 plus 4. And you can get the idea here. I'm pretty sure you guys have gotten the pattern at this point. So, pattern makes perfect sense now, doesn't it? It's going to be, well, go up by the amount of the row each time. So when we have 9 rows, we're going to need to start off with 9 cans on the bottom. 9 plus 8, so that's 17, plus 7, that's going to be 24, plus 6, that's going to be 30, plus 5, so that's going to be 35. And then we already got the rest of the problem done right here because we got for 4 rows. So it would just be plus 4 plus 3 plus 2 plus 1. And that, if you add it all up, should be equal to a grand total of 45 cans of Spam. And now we're going to move on to the next problem here. A library has 8 tables and 42 chairs. There are several small tables with 4 chairs each and some large tables with 6 chairs each. How many tables of each type are in the library? So we know there's 8 tables. That's important to know. We know that there's 42 chairs. That's also important to know. Now we know there's some of each of these large tables and small tables. So let's start figuring this out. The way I would like to do this is just by starting off by coming up with some possible ways of doing this. So let's go ahead and do this. So we got let's say there's 4 tables of each. So that's 1 table, one small table, 2 small tables, 2 small tables, 3 small tables, 4 small tables. Then we have the large tables. 1 large table, 2 large tables, 3 large tables, and 4 large tables. Okay, so if that was the case, 4, 8, 12, 16. So we'd end up with a total of 16 over here. At the bottom, we'd end up with, because there's 4 at each of these tables, and there's 6 at each of the large tables. So 6, 12, 18, 24. We add them all up together, and we see, oh, you know what? That's 40, which means we need more big tables, because the big tables have more people in them. So therefore, let's get rid of some of these small tables and go back instead and get to the big tables. So I'm going to go ahead and get rid of a small table here. And so if we get rid of one small table and we end up with getting another big table, that's now just going to get us to, instead of being what it was before, it's now going to get us just to, well, 3 times 4, that's 12. Right, 12. And now let's see if we are at the right place. Okay, and then 1, 2, 3, 4, 5. So that's going to be 5 times 6, so that's going to be 30. And hey, 12 plus 30, 42. I like to start off with them even because then I can go up or down either way, and it just makes it easier for me. So that's it, and those are just some examples of how to do this sort of type of problem, but you'll have to adjust it based on what the problem, the way that it's set up, and sometimes you have to think it out. And that takes a little bit of effort, but it can also be pretty interesting figuring out different ways of doing it.